And thank you for joining us today. It's great to have you with us. This session is all around beyond QVDs and building a trusted data foundation with Qlik Talend Cloud. We've had a number of customers sort of asking questions around, is a script-driven sort of QVD architecture still the right sort of long-term foundation for modern data requirements? There's a lot more needs on data and a lot more things that data is use cases for data. So we're going to explore how organizations are evolving their data architectures and how sort of Qlik Talend Cloud can help build a more scalable, trusted and governed data foundation. We're going to look at some of the challenges that organizations are facing as the data environments are expanding and why more of customers are moving towards a platform-led data integration approach rather than the current sort of QVD architectures that we know and have learned to love over the last 30 years in terms of, Qlik's best architecture. So, and sort of how this shift is going to help improve sort of ongoing trust in data landscapes. So this is going to be a short demonstration just to show how Qlik Talend Cloud supports the modern data integration and how organizations are moving beyond that sort of QVD-centric pipelines that we know. So before we begin, just a couple of quick housekeeping points. Everyone's currently on mute, so just help avoid any background noise. There is a chat panel and a Q&A just at the top right-hand side of the panel on your right, depending on how it's opened up on your browser. So please do feel free to add any questions or anything in that Q&A panel, and we'll come back to that at the end. And this session is recorded and will be shared to those that are registered and joined us today. So I would like to just take a second to introduce to our speakers who are joining me. So first we've got Tom Cotterill, who's our data integration lead here at Qlik. He'll open the session and talk through some of those challenges that I mentioned that organizations are facing with QVD architectures and why a lot of customers are starting to rethink the use of their data foundation. And then also joined by Andrew Dinning, who's a principal solutions architect at Qlik, and then he'll share his expertise on the modern data integration sort of platform and demonstrate how Qlik Talend Cloud enables organizations to build that trusted and scalable data platform that we're talking about today. Next slide, please, Tom. Hopefully, most of you on here already know who Qlik are, but for those that are new, just a quick sort of intro to who we are and what we do. So Qlik is a data and integration analytics consultancy founded in 2007. We've got offices all across Europe, across the Nordics, Sweden, and the Benelux regions. And as a group, we're around 100 consultants across the Qlik technology platform stack on data integration and both Qlik Analytics. In terms of customers, we have a variety of customers in pretty much every sector you can think of, some that I've not even heard of before until working at Qlik. We have a dedicated expert services team, which is like a managed service desk for support, so escalations and tickets and that kind of stuff. We also run dedicated training on both sort of Qlik integration, Qlik Analytics, and now we also just had our first Qlik AI training course this year, which is all around the Qlik Answers, Qlik Predict, and some of the AI capabilities in the Qlik platform, and that's all delivered through the Qlik Academy. And we do also run some free courses on that every quarter for sort of Qlik Analytics user-based training as well. As a group, in terms of, like say, the size of the consultancy that we have around 700 years of experiences if you were to add everybody's active time up in the field or in development. And then in terms of actual dashboards and solutions that we build across the group, it's around 500 per year that we deliver to a wide range of customers. So that's hopefully a quick whistle stop tour on who we are, what we do, and how we can potentially help you. And now, without further ado, I'll hand over to Tom to kick us off.
Thanks, Alex. Hi, everyone. So, as Alex explained, point of today is looking at what's happening with people's environments and why maybe considering moving away from your QVD architecture is not such a bad thing. So, what we're seeing across many Qlik environments is that QVD architectures, it's not that they're wrong. In fact, they're extremely effective, and they've been effective for a very long time. So the reality is that they were built for a different context. So when what often starts as a relatively simple reload for analytics, it gradually becomes something much more central. It becomes the data platform the organization starts depending on. And as that shift happens, expectations change. So there's much more demand for scale, faster change, broader reuse, and of course, people want more trust in the data. So this session is about, it's not about replacing something that's broken, it's about recognizing that the role of data has changed and the architecture needs to evolve with it. So the question is no longer, how we optimize QVDs, it's whether they're still the right foundation. So where the issues with QVDs start to become visible is in how the environment behaves over time. As organizations grow, demands placed on the architecture changes, and this is where pressure begins to build. So one of those pressure points is scale. So data volumes increase, but more importantly, the number of sources, pipelines, and dependencies also increase. So what was once a small set of QVDs becomes a large and interconnected estate. So then there's change. Organizations want to add new data sets quickly. They want to adjust logic or respond to new business questions. In script-heavy environments, every change requires careful modification of existing reload chains. And there's another factor of reuse. So data is not just consumed by dashboards anymore. It's used in data science, operational systems, governance workflows, and increasingly AI initiatives. A QVD layer built primarily for analytics it's not always designed to support that wider use case. And of course, governance is becoming more important to organizations, especially as they mature. They need clearer visibility into lineage, monitoring, and reliability across their data pipelines. This becomes harder when the behavior is embedded across many individual scripts. And of course, there's AI expectations. So modern initiatives, they expect data foundation that's structured, traceable, and continuously updated, not just refreshed through periodic reload jobs. So the question organizations are asking, it's not whether QVDs are useful. The question is more really, are they still the best foundation for the trusted data pipeline, trusted data platform that we need today? And that's the conversation we want to explore in this session. So QVD architectures were incredibly effective. It's really important to recognize that QVD architectures are actually brilliant for what they were designed to do. They gave organizations extremely fast analytics, complete developer control, and very tight integration with the Qlik engine. The performance aspect was particularly powerful because QVDs are native, optimized format. They allow Qlik to load very large data sets extremely quickly. For many organizations, this made interactive analytics possible, and this is at a time when most tools struggle with performance. The second strength is really around developer control. Everything was explicit in the scripts. Developers could see exactly how data moved through the system. They could shape the logic however they wanted, and they could build pipelines that were highly tailored to the business. That flexibility is really one of the reasons why Qlik environments could evolve so quickly. And finally, there's tight integration with Qlik itself. The storage format, transformation logic, and analytics were all part of the same ecosystem. That meant fewer moving parts and very efficient reload cycles. So it's important to say clearly, QVD architectures solve the analytics problem really, really well. So what we're going to explore next is why the environment around them has changed, why organizations are now asking whether the same architecture can still serve as the entire data platform. So what has changed? So the reason organizations are revisiting their architectures isn't that QVDs suddenly stop working. It's that the environment around them has changed significantly over the past decade. So the first change is simply there are more systems. So most organizations now operate across a much broader technology landscape, cloud applications, operational platforms, SaaS tools, and partner systems. That means many more data sources and pipelines connecting to them. Then, of course, there's more data. So data volumes have grown, but more importantly, the variety and the velocity of that data has also increased. So what used to be perhaps maybe a periodic batch load is now expected to support near real-time analytics and operational reporting. And of course, there's governance. So organizations become more data-driven. There's a much stronger requirement to understand where that data came from, how it was transformed, and of course, whether it can be trusted. So that requires visibility into pipelines and lineage, and this historically sat inside scripts where it was hard to get. And then we've got reuse. So data's no longer just consumed by dashboards. It's increasingly used in data science, operational systems, machine learning, and of course AI, which means the data foundation needs to support multiple consumers, not just an analytics layer. So what we're seeing is that organizations now expect their data environment to behave less like a reporting pipeline and more like a shared data platform. And that shift is where traditional QVD-centric architectures start to feel a bit stretched. And also there's a hidden cost in that QVD-centric layer. So once QVD environments grow beyond their original scope, there's a number of operational patterns that tend to appear. None of these are necessarily wrong, but over time, they're going to introduce hidden complexity. So the first one is script-heavy onboarding. So when a new data set needs to be introduced, so developers typically have to write new extraction logic, transformation scripts, and incremental logic. This works well, but it means every new pipeline becomes a small development project. Then there's custom incremental logic. So incremental loading is often implemented manually inside scripts. That includes logic for handling updates, inserts, error conditions, restart scenarios. These solutions work, but they also mean the behavior of each pipeline can be slightly different, especially if it was built by different developers. The third issue is knowledge concentration. So because the logic is embedded inside scripts and those reload chains, understanding how the environment works often depends on the developers who built it. In many organizations, a relatively small number of people carry a great deal of knowledge, particularly operational knowledge about those pipelines. And then finally, there's fragility during change. So making modifications, if it's adding a new data set or just making a change to an existing pipeline, it requires careful work across multiple scripts and dependencies. So the cost of change increases as the environment grows. What's important here is that these costs don't show up during normal operation. The system may run perfectly for years. The real cost appears when organizations need to change something quickly or explain how the system works or scale the platform further. So up to this point, we've talked a lot about the pressures that organizations are experiencing as their environment grows. But it's important to be clear about something. The problem isn't QVDs. QVDs, they remain extremely effective for analytics workloads, and they'll likely continue to do so for a long time. The issue appears when the QVD layer gradually becomes the entire data platform. So what started as fast analytics storage layer ends up carrying more responsibility, particularly for data ingestion, transformations, change handling, and operational reliability. Those are all responsibilities that traditionally belong to the data integration platform. Excuse me. Where they're implemented entirely through scripts, the architecture starts to become harder to scale and harder to evolve. So the shift organizations are making isn't about abandoning QVDs necessarily. It's about separating the responsibilities of the data platform. So instead of using the analytics layer to do everything, organizations are starting to introduce a dedicated integration layer that manages ingestion, manages change handling, and pipeline behavior consistently. And that's the architecture shift we're going to look at next. So where does Qlik Talend Cloud fit? So what this diagram shows is where Qlik Talend Cloud sits within a modern data architecture, particularly with AI lilt. So the key idea is the platform separates two distinct responsibilities. On the left-hand side, we've got the AI foundation, which is where the data platform work happens. This includes data integration, transformation, quality management. The role here is to move data from source systems, apply transformations, and ensure the resulting data sets are reliable and, more importantly, trusted. In the middle, we've got access. This represents a point where trusted data sets become available to different consumers across the organization. And on the right-hand side are AI solutions and analytics. This is where data is used for dashboards, advanced analytics, machine learning, and operational applications. So the key architectural principle here is that the data preparation and the data consumption are separated out. And underneath, you can see the platform capabilities that support this layer. Things like real-time data movement, hybrid processing, data products, governance, automation. So these are the capabilities that allow the platform to behave consistently without requiring custom logic in every pipeline. And finally, at the bottom, you can see the open ecosystem the platform integrates with. So Qlik Talend Cloud's designed to work with modern cloud platforms and storage technologies, so Snowflake, Databricks, Google, Microsoft, and of course, open table formats like Iceberg. So the platform isn't replacing your data environment. It's acting as the integration and governance layer that connects everything together. So what we're going to do next is move from the architecture to something a little bit more practical. So up to this point, we've talked about the architectural shift conceptually, and what we'd like to demonstrate is the shift from a traditional script-driven pipeline where behavior is implemented manually, and show you the platform-managed pipeline where many of those responsibilities are handled by the system. So the focus here it isn't on features of the platform, it's on how the platform changes the operational behavior of the data pipeline. So with that, I'm going to hand you over to Andrew from Qlik. He'll give us a walkthrough and a short demonstration of how this works in Qlik Talend Cloud. So thank you, Andrew.
Thanks, Tom. So as Tom mentioned, I want to demonstrate how the Qlik Talend platform can act as that trusted data foundation to increase data reuse, increase governance, and trust across your organization. In order to do so, I want to call upon some of the key capabilities that Tom's already mentioned, focusing on data movement, data transformation, data trust and quality, and access. But in order to do so, I really want to use the Qlik Talend Cloud platform through 3 different lenses today. So I want to focus on a couple of different personas. The first persona I want to look at is the data engineer. So if we think of the data engineer as typically being responsible for sourcing data from a wide range of sources, making that available within the organization in a transformed and trusted format ready for use. As part of the example today, I want to have a look at, if I was part of my organization, how we could maybe manage customer churn a little bit further. So in order to do so, I've started to build out a data pipeline, which we can see on screen. Now, part of the data I need to understand customer churn is data around customer and their buying patterns. So you can see we've already onboarded some source data from the likes of Salesforce, which is using automatical incremental reloads of refresh of data to incrementally get the latest data from Salesforce, as well as more relational sources such as MySQL, again utilizing techniques such as log-based change data capture for near real-time data replication. Now, whilst this is serving my use case to start with, frankly, in order to really understand customer churn, I understand that I have a lot more disparate sources of data within my organization, which could really add value to this data pipeline. Then sources could be things like Google Analytics, how much of my customers interacting with my web presence. Maybe I've got e-commerce stores through eBay or Shopify. Maybe actually I want to bring in social media data to understand how much my customers are interacting with me on social media. And here you can see a range of out-of-the-box connectors provided by Qlik Talend Cloud in order to bring in them important data sources from across the organization. So far I've sourced some data from some different platforms and made it available into my underlying data platform. In my example today, I am using Snowflake. However, as Tom already called upon, Qlik is a platform agnostic. So this doesn't matter if you're using Snowflake, Databricks, AWS, Azure, or even more modern open table formats such as Iceberg. Qlik can be that independent data integration platform to serve all of those data needs. Now, the second element of my role as data engineer is I need to make sure that this data has been transformed and is business ready. So in order to do that, let's go and have a look at some of my transformation steps. Because I'm using a platform like Snowflake, I've chosen to follow a medallion architecture. This is landing data into a bronze layer, standardizing and transforming that data into a silver layer, and then making that analytical ready in that third golden layer. So what we can see on the screen here is on the left-hand side, all of the source data sets that we've just sourced from these data sources, and we can think of this as landing into our bronze layer. On the right-hand side of our screen, we can see the target data sets. So these are the data sets made available to my silver layer, which have gone through a range of transformation processes, which nicely calls upon what we can see in the middle of the screen. These are the transformations that we're currently providing on top of this data. Again, Qlik Talend Cloud wants to open up capabilities to a number of personas and users within the organization. So if we were to have a look at one type of transformation, which we can refer to as a SQL transformation, this is to allow more of a code first approach to data transformation. Here as a data engineer, I've been quite comfortable writing the SQL code required in order to achieve my desired outcome. In this particular example, you can see I'm actually taking some service ratings to categorize them into bands to get some overall banding of how well my customers have had an experience with my online platform. I can also start to use things like our SQL Assistant to actually either help me within a productivity format to make me more productive as a data engineer, or maybe to help me with some complex code I wouldn't be quite capable or comfortable with writing natively. Here we can see I've passed it a natural language prompt, and Qlik has gone and interpreted what I'm after doing, and has actually generated me some SQL code, which is quite similar to what I had already wrote. Again, maybe we want to change personas a little bit here to more of a citizen data engineer. So maybe someone who isn't quite as comfortable writing SQL code. Through the use of our transformation flow, you can see a drag and drop low code, no code interface of where users can still engineer data, perform transformations, and actually make this data fit for business use. Down the left-hand side, you can see a range of different processes here we can perform upon this data. Again, if I maybe just wanted to add to this particular transformation flow, I can just go and drag and drop in an additional processor into this flow. In this use case, I want to go and remove some columns. I want to make sure that the data we're making available for my organization doesn't have all of the necessarily detail that I might not want to share. So things around base fees or start dates and cancel dates around contracts, I might want to go and drop them out of my process. Again, we can achieve the same level of transformations that someone with a pro code approach can take through SQL, but again, just in order and a citizen data engineer to achieve the same capabilities. If I was to jump back into my pipeline now, the last thing I want to call upon is the final step in my process around creating gold level data marts. If I open up my data mart task, here you can see we've created a range of dimensional models ready for consumption through analytics. Again, importantly, using low code, no code interfaces, allowing for productivity and acceleration to insight. So if I have a little bit of a recap there on that first persona I wanted to look at, we can see as a data engineer how we can quickly ingest data from a range of different sources through a range of different techniques, whether that be real-time log-based change data capture or more incremental reloads from SaaS-based sources. We can make that data available to our underlying data platform, again, providing an agnostic capability here to allow you to choose the right data platform for your organization. We can transform that data and make that data available for analytical use. Now, I want to slightly change tack now. So we've got some analytical data ready in our underlying data platform. So now I want to change persona slightly and take on the cap of a data product manager. It's up to me as a data product manager to now make this data available for use by the organization, whether that's to be used by Qlik Analytics or third-party tools as well. So as I come into my data product catalog, you can see here we've already got a range of data products which have been created around different business domain areas, whether that be promotional offers, purchasing, sales orders, or maybe more HR products. However, I did set out my stall at the start and say today we're focusing on some customer churn example. So right now I don't actually have a data product where if a business user wanted to come and started doing some analytics on customer churn, they wouldn't know where to go. So let's create a brand new data product here. I'm going to give my data product a name of customer churn, and I'm just going to choose a space of where I want this data product to live. As we now go to build out this data product, the first thing I want to do is add some data. I want to build out this data product. This is where I can go add data sets which have either been onboarded by Qlik Talend Cloud or already available in different data platforms or within my Qlik ecosystem. As you might expect, in order to understand customer churn, maybe I need some information around sales. Maybe I want to know a little bit more around what products my customers are actually buying, just to help me understand that sales process a little bit more. And importantly, as you would definitely expect, I definitely need to understand some information around my customers. As I hit OK now, you can see the different data sets that I've included as part of this particular data product. So as the data product manager, this is me saying to the organization, here are the different data sets that you would require if you wanted to do some analysis upon customer churn. There's a couple more things I want to do at this stage. So if I just quickly jump to API endpoints, I'm going to make all of these data sets available via an API endpoint. This will become a little bit more obvious in terms of what this capability is doing when I switch into that final persona of data consumer. So we'll revisit this later. The last part of this process is I want to add some key contacts. For any of my data consumers using this data product in practice, I want them to fully understand who they should contact if they have any issues. So I'm just going to go ahead and add myself as the data product manager in this particular example. Here we can start to understand a little bit more about our data product. Already you'll see we've got this concept of a Qlik trust score. How much should we trust when we come to use this overall data product? You can see we also get the trust score on an individual data set level. Let's have a little look at this in a little bit more detail. As I dive into a product data set, you can see we have the Qlik Talend Trust Score. The Qlik Talend Trust Score is a configurable weighted metric made up of several dimensions such as validity, accuracy, and completeness to give me an overall trust score. So when I'm a business consumer and I'm looking to engage with this data, I understand how much I should trust this data. We can see the trust score is quite low for this particular data set at only 2.2 out of 5. I can quickly improve this by maybe just adding some descriptions, whether this is adding a description for the particular data set or all the underlying fields we can find in this data set. Again, I can do this manually or through the use of AI, I can actually make some suggestions for me. As I hit save now, you can automatically see the improvement that's had on the Qlik's trust score. Again, improving the trust and usability of this data within my organization. We can also monitor the history of this trust score as well to make sure that we're doing the right thing within the organization and continuously improving and driving improvement across our data. Trust is not just about validity and timeliness, it's also a large part about data quality as well. So here, if we have a look at our data quality bar, we can actually start to understand how much percentage of this data is valid, where we've maybe got empty or null values, or actually where we've got incorrect valid values in here as well, where we need to do something about that. If we would hit in our data preview tab, we can start to preview this data and we can start to see in context, where do we maybe have missing and null values, or actually where do we have incorrect values within here. I'm going to leave remediating and actually improving this data for another time. As I come back to my data product now, the last part in this process is I just want to make this data product available. So I can choose to activate this data product and make it available directly within my marketplace. And this is where I want to swap over to my final persona here, the data consumer. And with this persona, if I was coming to my data marketplace, this is where I can start to see published data products available for particular use cases. Again, I can start to search for data products which is going to fit my particular analytical need. As we know in this case, it's understanding churn. I've got one data product here around customer churn. Now, as a business user, as I open up this data product, I can start to use this pre-built asset for me. I can start to understand things like its documentation. I can start to look at the lineage as well to understand any transformation process this data product has gone through. I can also start to trace this all the way back to my underlying source database to actually make sure it's coming from the production and operational system that I would expect. But at this point, I want to do a level of analysis. So I can either use this with an API endpoint. So already I've now got an OData endpoint where I could go start and consume this directly within Excel or maybe third-party visualization tools. However, with a press of a button, I can already start to load this data into a Qlik application to perform that real-time insight. And there we have it, Tom. We've seen how as Qlik Talend Cloud, we can use it to provide that trusted data foundation, allowing you to source data, transform data, and provide a level of trust and governance on top, ready for consumption.
Fantastic. Thanks very much, Andrew. Really appreciate that. So what Andrew's shown us isn't just how, it's not just a new interface or a new tool. It's essentially demonstrating what's going to change operationally. So the first thing I think you can pick up from there was there's going to be less custom data plumbing. So instead of writing and maintaining scripts that move and shape data, much of the behavior becomes platform managed. So as you saw in the demo, pipelines are defined once, and then it can be handled consistently by the platform. Secondly, we've got full pipeline visibility. So instead of individual scripts running in isolation, pipelines become observable end to end. You can see how data sets flow through from landing, storage, and transformation all in one place. The third, probably most importantly, we've got consistent data behavior. So things like incremental loading, schema evolution, even retries and recovery become standardized. So this removes, a lot of the variability and the fragility that typically appears in script-based pipelines. Alongside that, you start to see concepts like data products and trust scoring emerging. So where data sets are not just created, but they're governed, measurable, and reusable. So the shift is not just about moving data differently, it's about running a more predictable and governable data platform. So what's the platform value that's being unlocked? So step back from the mechanics of the pipeline and platform. What this really unlocks is operational value for the data team and the organization. First off, we've got lower marginal cost per data set. So once the platform and the pipelines are established, adding new data sets becomes significantly easier. You're no longer building everything from scratch every time. There's faster change. When pipelines are managed and observable, changes to sources or schemas can be handled much more efficiently. This means the platform can evolve with the business instead of slowing it down. And then, of course, we've got reduced dependency on individuals. So many script-based environments, critical knowledge can often live with one or two developers. The platform-driven pipeline makes that logic visible and repeatable across the team. And finally, better trust and governance. So with lineage, monitoring and managed pipelines and trust scores, organizations gain much clearer visibility into how data is created and delivered. So the real shift is moving from hero-driven data engineering to a predictable, scalable data platform. So what we discussed today isn't really about replacing one tool with another. It's about changing the way the data platform operates. So moving from environments built around custom scripts, fragile pipelines, to a governed platform designed to scale with the organization. Qlik Talend Cloud provides that foundation by combining data integration, quality, and governance in a single platform. This allows organizations to modernize their pipelines without disrupting the analytics that they rely on, and ultimately allows the data team to focus less on manipulating and plumbing and more on delivering insight and value. So I just want to say thank you very much for joining us today, and we're happy to take any questions.
Perfect segue that, Tom, because we've got a few in the panel. So I don't know who this one's going to be based for, but I'll read it out. It's is it possible to make new tables based on other tables with multiple exists, match, or other functions in the where clause, like is now possible in Qlik scripts in Talend Cloud through pipelines? Joe, is that one for you?
Yeah, I can take that. I mean, I'm just having a quick relook at the question. If I understand the question correctly, I mean, if I take my example, for example, say my example, for example, sorry, where we've got our bronze layer and we're producing that silver layer, if we load one customer table into bronze, we could have multiple outputs into that silver layer. So that could be partition that by region or years or dates, provide multiple where clauses. One of the key things is because we're using a push down architecture, so all that SQL code we're generating, where that's pushed down in that underlying data platform. So for example, Snowflake in my instance, any SQL code which would run in that underlying Snowflake platform, you can use and call upon directly within the Qlik Talend Cloud platform as well.
Yeah, yeah, and just to add on that, during Andrew's demonstration, in one of his SQL transforms, I think you actually saw two individual tables coming into that one. So I think that might be what you're driving at. You can have multiple tables going into one of those, either the SQL type query or the transformation flow type query.
Awesome. Hopefully that answers your question. Another one that we've got is around the trust score. So once a trust score is established, how can you actually manage or modify it as data quality or data pipelines change over time? I'm guessing,
Yes,
Andrew, that's one for you.
I'll
Yeah.
take that. Yeah, great question. So imagine if we onboarded some data today, you profiles the trust score, gives you a number. One of the things you've seen there is you can periodically see the historic data. So you can always continuously manage the score. Is it improving? Is it decreasing? In what particular areas may it be improving or decreasing? And importantly, drive process change within your organization to make sure you're continuously improving. The other thing which is worth calling out, which we didn't see in today's demo, was around the personalization of that trust score as well. So every organization, if we look at the trust score, we had factors in there such as accuracy and completeness and timeliness. That's all going to slightly change between everyone's different organizations and their different priorities. So you can choose how that trust score is weighted. You can also build in custom validation rules and semantic logic. So for example, in some organizations, if I pick a simple example, a purchase order number might be 10 digits long. In a different organization, it might be 14 digits long. So you can start to choose unique tweaks like that to actually understand, okay, what is a data quality issue for my organization? You can also start building your own validation rules and business logic for things like product catalogs, customer lists, things like that as well, to make sure that trust score is really personalized to your organization.
And just what's an addition from me, really, it's not in that question, but I'm guessing a trust score is a dynamic thing, so it will change as things change that feed it. Can you also set sort of alerts and sort of outputs? So if a trust score does improve, you can send out a notification or an alert to say your trust score is now at a certain point, and can you set alerts, I suppose, on the other way to say your trust score really needs work, please, take a look at it.
Absolutely, yeah. And you should really look at it as a trust score. Trust score is really about a business process around driving data improvement and increasing trust within the data. So you absolutely should look at it as a proactive, ongoing process within your organization.
Cool. And then thanks, Andrew. Cheers for that. I know we're just on time, but I've got one more question, if that's all right, if we can overrun slightly. And this is perfect for the session today. So it says we've got quite a lot of QVD based pipelines in place currently. If we're looking towards moving to a solution like Qlik Talend Cloud, how would that transition typically work without breaking what we've already built or what we've got already, I guess?
Yes, I can take that one, Andrew. Jump in if you feel the need. So, I mean, essentially, what the main recommendation is that you keep what you've got already. So you leave what you have already running, and then you build the QTC in tandem with that running system. So that means you can keep what you've got until the new infrastructure is ready to take over the analytics. I don't know if you've got anything else to add to that, Andrew.
No, the only thing I'd add to that, Tom, is really, when we look at where customers have done this in the past and where they're currently doing it, there's a lot of business priorities which shift the priority of where do you start first. One of the key things myself and Tom have mentioned today is the reuse of data outside of QVD architectures. So obviously within your organization now, if you're seeing new needs for AI or ML, obviously the data required for them particular use cases would just typically drive your priority.
Good point.
Great stuff. Well, thanks ever so much. That's all we've got time for today. So thank you to everyone who's joined us and spent the time with us this afternoon. Hope you found that the session valuable and learnt something from it. We will be sharing the recording of today's session in the coming days, so that will be sent out to everyone who's joined us. If you would like to discuss any of the points today, or how to evolve or modernize your current QVD architecture, then please do get in touch, and we can further the conversation. But I think for now that's everything, and enjoy the rest of your day. Thank you.
Thanks, everybody.
Thanks, everyone.